This isn't just a step forward in finding dark matter. It's like stepping into a whole thing. Quantum computing, which used to be just a cool idea, is now strong enough to poke around at how the universe is built. Intel and its buddies are making this tech better. We might totally change how we get dark matter and the hidden rules that run everything. The heart of this change is using good hardware with quantum algorithms. These setups can now pick up on not just the dark matter stuff going by, but also the little messes it makes in quantum fields. So, every time they spot something, it's like getting a peek into a part of reality we couldn't see before. These processors will get so good that they can find not just WIMPs, but other weird particles that physics guys have only thought about. Instead of just trying to see dark matter head-on, we're figuring out how it messes with fields. Think of it like this. Instead of watching leaves to see the wind, we're mapping the wind by looking at how it moves tiny particles. Dark matter is like the wind. We can't see it, but it's there. The way galaxies spin, how light bends around stuff, and how the universe is put together all point to it. Now, with this jump in tech, we're spotting dark matter not by the chaos it causes but by the little marks it leaves on the quantum level. What's so cool is that we can check these findings in a totally new way. Quantum setups can make stuff happen that we can measure and do again, so different labs can try it out and see if they get the same results. Some early tests are already going on at big places, and they're going to put out what they find soon. If it checks out, it'd be a huge deal not just for finding dark matter but for science in general. And it doesn't end there. NASA is getting in on this, so we might be able to put quantum sensors on satellites and make 3D maps of dark matter across the whole universe. These maps could tell us how galaxies form, change, and hang out together, which would answer some old questions and bring up new ones. But it's not just about space stuff. The same tech we're using to spot dark matter messing with quantum fields could be used to look at the weird quantum forces behind gravity. Some brainiacs think that if we make these setups even better, they could find the graviton, which is supposed to be a quantum particle that makes gravity happen, but everyone thought we couldn't see it. If that happens, we'd be closing a big gap in physics between quantum mechanics and general relativity. We also might learn about the universe's early days. The quantum messes caused by dark matter could give us clues about what went down shortly after the Big Bang. Maybe we'll even find out if dark matter helped the universe inflate, expand, and spread stuff around. Scientists are already changing their models to include these new quantum dark matter findings. As we learn more, people from different fields are teaming up. Particle physicists, quantum engineers, space dudes, and computer scientists are working together now, smashing down the walls that used to keep them apart. Intel is building its next quantum systems with these big goals. These processors won't just hunt for WIMPs. They'll be set up to scan for all sorts of weird particles and field changes, each with its own quantum fingerprint. What's crazy is how these algorithms get better over time, learning to tell the difference between a real signal and just noise, kind of like how early radar learned to tell birds from planes. Things are moving fast. They're already testing prototypes of the next detection units in space, trying to copy space-based detection conditions. They're trying to get around the Earth's atmosphere to get better sensitivity and accuracy. Space quantum systems could eventually watch dark matter stuff in real time, logging and checking things out across the universe. Now, people are wondering, if we can spot dark matter this way, can we mess with it? Could we somehow use its quantum properties to make energy, move stuff, or send data? These are crazy questions, but in a field where a system running on less power than a light bulb just changed 4 decades of failure, anything seems possible. This system did what old-school science couldn't. It gave us solid proof of dark matter through the ripples it makes in quantum systems. We're not just looking for a needle in a haystack. We're changing how we look for the needle. A quantum system that picks up on theoretical WIMP signals, runs at room temperature, and uses about as much power as a household appliance has shown us that dark matter might mess with normal matter through the ways we never predicted. It's changing how we think about galaxies, adding to the standard model, and pushing us toward a single theory of physics. As companies like Intel make bigger quantum processors, we might soon be able to map the dark matter structure of the universe in detail. For the first time, we're not just making stuff up about the 85% of the universe we can't see. We're starting to mess with it. The idea that dark matter could be more than just a background player is catching on. With new signs of active quantum stuff going on, Researchers are starting to think of dark matter not just as a gravitational glue, but as something that helps the universe change. If it really does mess with the quantum field in ways we can measure, then dark matter might be part of a deeper law of physics that's been in front of us the whole time. Some physicists are thinking about whether dark matter could be a type of matter hidden in higher dimensions, only showing itself through how it affects quantum systems. This fits with some ideas from string theory where our universe is just a 3D slice of a bigger reality. Recent quantum detections might be the first clue that these dimensions exist. We can't see them, but we can see how particles act as if they're being pulled by forces from beyond our 4D world. These ideas aren't out there anymore. Quantum sensitivity and AI-powered checks are giving us resolutions we never thought possible. Quantum algorithms are being trained not just to spot what we know, but to find totally new stuff, weird signatures that don't fit with WIMP models. We're taking these unknown unknowns seriously as proof of physics that we haven't even made up yet. And here's an even crazier thought. What if quantum computers aren't just for finding dark matter, but for finding laws of nature that we haven't written yet? Old experiments test theories, but these new setups could make them. The data they give us, full of weird patterns, might be the stuff we need to build new theories. We're not just trying to prove what we expect to find anymore. Now, we're asking, what's the universe trying to tell us? And do we even have the words to describe it? This change is shaking things up. Schools are changing what they teach to include quantum information science in space stuff. Because the big finds of the future will happen where they meet. Private companies, space agencies, and global science groups are teaming up to speed things up. They're combining quantum tech and cosmic data to build a network for spotting dark matter. Basically, a quantum telescope internet. At the same time, ethics experts are starting to think about what this all means. If we can see and maybe mess with the hidden 85% of the universe, that brings up some big questions. If dark matter reacts to quantum systems, could smarter aliens have used this a long time ago? Are we just finding old principles built into the cosmos? As we stand on the edge of these finds, we're aiming for bigger things. Detection was just the start. Now, scientists want to map, classify, and maybe even use dark matter in useful ways. Quantum-powered navigation that adjusts for dark matter changes. Communication tech that uses quantum field changes as signals. Energy systems that use the changes in the dark field. Things that used to be sci-fi are now being modeled in labs. At the heart of it, one thing is clear. For the first time, we're talking to the invisible guts of the universe. We're not just guessing anymore. We're connecting from the inside. Every ripple spotted by a qubit isn't just an observation. It's a handshake across the void. A sign that the dark, silent majority of the cosmos is not only there, but it's listening. What started as a long search driven by old physics has been changed by quantum innovation into something much bigger. We've made contact. The once invisible stuff that shapes galaxies, controls gravity, and outweighs the known universe has finally shown itself. It's done it, not through smashing things together, but through quiet whispers in the quantum world. Intel's quantum processor, running at room temperature with a small amount of energy, has changed the game from guessing to showing. It's turned old ideas on their head, proven that we don't have to just watch dark matter, and changed how we find it. We now know that dark matter messes with quantum fields, leaves a mark when it passes, and might have properties we don't even know about yet. This isn't just a step for particle physics. It's a rebuild of the cosmos. We're seeing the outlines of a new model, not just based on what we can smash together, but on what we can connect, trace, and guess from the quantum fabric of reality. The effects will spread. From space to medicine, from weather predictions to materials, from how we understand time and space to how galaxies form. We now have the tools, the ideas, and, importantly, the questions. We're not just looking into the dark. We're starting to light it up. By doing that, we're changing our role in the universe from watchers of its secrets to people involved in its most basic interactions. And that might be the craziest idea of all. And it's not just about space. The same tech that finds dark matter messing with quantum fields could be used to look into the weird quantum forces behind gravity. Some scientists think we could even find gravitons, particles that cause gravity, which we thought we'd never see. If that happens, it would tie together quantum mechanics and general relativity, which are like the last big puzzle pieces. We might also learn about the start of the universe. Quantum changes from dark matter could tell us what happened right after the Big Bang. Maybe dark matter even helped the universe grow super fast and spread stuff around. Scientists are already changing their ideas about the early universe because of this new info. As things move forward, people from different fields are working together more. Physicists, engineers, space experts, and computer folks are teaming up because quantum computing is too big for one group to handle. Intel is making its next quantum systems to do all this stuff. These processors won't just look for WIMPs. They'll look for all kinds of weird particles and field changes, each with its own quantum signature. What's amazing is how these computer programs are getting better at telling what's real and what's not, like how old radar systems learn to tell birds from planes. Things are moving fast. They're testing early versions of these detectors in space to see how they work. Being in space avoids problems with the Earth's air, making things more accurate. Space-based quantum systems could watch dark matter all the time, tracking what happens across the universe. Now, people are wondering if we can not only see dark matter but also mess with it somehow. Could we use its quantum stuff for making energy, moving things, or sending info? These are big questions, but in a field where a system that uses less power than a light bulb just changed everything, anything seems possible. It did what old science couldn't: show hard proof of dark matter by the little waves it makes in quantum systems. It's not just about finding something small. It's about finding it in a totally new way. A quantum system that finds WIMP signs, works at room temperature, and doesn't use much power has shown us that dark matter might be connected to regular stuff in crazy ways we never thought of. It's changing how we think about galaxies, adding to the standard model, and getting us closer to a unified theory of physics. As companies like Intel make bigger quantum processors, we might be able to map out the dark matter structure of the universe in detail. For the first time, we're not just guessing about the 85% of the universe we can't see. We're finally interacting with it. Shall I keep going? You said go on. ChatGPT said the thought that dark matter might do more than just sit there is becoming popular with scientists. New stuff suggests it does quantum things, so researchers are seeing it not just as something that holds things together, but as something that changes how the universe works. If it messes with the quantum field in ways we can measure, then dark matter might be part of some deeper rule of physics that we haven't seen yet. Some physicists are wondering if it's a type of stuff that's in a higher dimension and we can only see it by how it affects quantum systems. This idea fits with some theories that say our universe is just a small part of a bigger reality. The new quantum findings could be the first hint that these dimensions exist, not by seeing them directly, but by how particles act as if they're being pulled by forces from somewhere else. These ideas aren't weird anymore. Quantum stuff and machine learning are giving us details we never thought we could get. Computer programs are being taught to find not just what we already know but totally new things like signs that don't fit with WIMP models. These unknowns are being taken seriously as possible proof of physics we haven't figured out yet. And that brings up a bigger idea. What if quantum computers aren't just tools for finding dark matter, but ways to find laws of nature we haven't written yet? Traditional setups test theories, but these new setups could make them. The data they give us might have the stuff we need for future theories. We're not just checking what we expect to find. Now we're asking what the universe is trying to tell us and if we even know the right words to describe it. This change is shaking things up everywhere. Schools are changing their programs to teach quantum infoscience with space stuff because they know the next big finds will be in both areas. Tech companies, space groups, and science groups are teaming up to make things faster, sharing stuff to build one big dark matter network like a bunch of quantum telescopes on the internet. Also, people who think about ethics are wondering what all this means. Being able to see and maybe mess with the hidden 85% of the universe brings up some big questions. If dark matter reacts to quantum stuff, could smart aliens have used these reactions a long time ago? Are we just finding old ideas that are already out there? As we find all this new stuff, our goals are growing. First, we wanted to find it. Now, scientists want to map it, sort it, and maybe even use it. Like making better navigation systems that know where the dark matter is, communication tech that uses quantum field changes, and energy systems that use dark field waves. Things that used to be sci-fi are now being tested in labs. And the main thing is, for the first time, we're talking to the invisible stuff that makes up the universe. We're not just guessing from the outside, we're talking to it from the inside. Each wave spotted by a qubit is a hello across empty space, a sign that the dark part of the universe is there and it's answering. What started as a long search has now become something bigger thanks to quantum computing. Contact, the invisible matter that silently shapes galaxies, controls gravity, and is way bigger than the visible universe, has finally shown itself, not by big crashes, but by small whispers in the quantum world. Intel's quantum processor has changed things from guessing to actually talking. It has proven wrong the idea that dark matter just sits there and we can only watch it. We now know that dark matter messes with quantum fields, leaves a mark when it goes by, and might have stuff that's beyond any type of particle we know. This isn't just a jump for physics. It's a change in how we see everything. We're seeing the outlines of a new model, one that's not just about what we can smash together but what we can connect, trace, and guess from the quantum stuff of reality. The results will be huge, from space to medicine, from weather to materials, from how we see time and space to how galaxies form. We now have the tools, the ideas, and the questions. We're not just looking into the dark. We're starting to light it up. And by doing that, we're changing our role from just watching the universe to being part of it. And that's maybe the biggest thing of all.